Hello, welcome to this edition of Momentum from the Bagley College of Engineering at Mississippi State. I'm your host, Robert Green, and I'm glad you joined us. And I'm happy today to be joined in the studio by Dr. Clay Walden. Dr. Walden is the Executive Director for the Center for Advanced Vehicular Systems here at Mississippi State, or as we always call it, CAVS. Dr. Walden, welcome.
Well, thank you. I really am glad to be here, Robert.
Yeah, we're glad to have you here. So start a little bit by telling us about CAVS. How did it come to be? Where did it come from? Sort of what is its function?
Yes. So CAVS began in the 2001-2002 timeframe when Nissan came to Mississippi.
Yeah.
That was a watershed event for our state and certainly for our university. And as a result of that economic incentive package, we established two facilities, one here at the Research Park, and then our sister unit down in Canton that's close to the Nissan plant. The idea was to really take our research and our engineering outreach and apply it to challenges that relate to the automotive or the vehicular industry.
Okay. And now it sort of came from our engineering research center we had at one point. How's that relationship? How did that evolve?
Yeah, it's an incredibly important relationship. The NSF's ERC, as we call it, was another watershed event for our university and our college. It really put Mississippi State on the map, where we became a player in multidisciplinary research focused around high-performance computing and computational fluid dynamics. That experience was the preliminary experience to CAVS, and CAVS, in fact, was patterned after the Engineering Research Center for the National Science Foundation. Our organizational approach was based off of that successful work in the 1990s.
Okay. Well, a couple of episodes back, we had Dr. John Ball on here, and Dr. Ball, of course, electrical computer engineering faculty member, is advisor for EcoCAR.
Yes.
And I know you're very involved with that,
yes.
Sponsor that both financially and with space out there at CAVS. Tell us a little bit, how does EcoCAR benefit you? What do you see how it benefiting our students?
Yes, well, yeah. It benefits me because I love it. I love our students, and it gives me a chance to really engage with students in a way that I haven't been able to for several years. And so we're very pleased to host the EcoCAR activities at CAVS, to provide technical advisors to them where we can, but certainly provide a kind of an overall business mentoring and business support angle. I chair the internal advisory board that's made up of the department heads and others to provide guidance and encouragement to our students. I could not be more pleased with every team we've had since I've been there. In fact, we always brag about them. Every tour I give the CAVS, I brag about the EcoCAR. And one of the things I brag the most about is, even though while we're proud of our baseball team, they weren't the first team national champion.
It's true. True. Yeah.
Yes.
And since we had Dr. Ball on, we've completed this year's competitions out at Yuma, Arizona.
That's right.
And our team did very well, brought home several trophies for that. So very proud of them.
No, I am too. I am too. They learn a lot. They learn things you can't learn in the classroom.
True.
You learn about people, first and foremost. You learn about project management. You learn about managing technical risks in a constrained time frame. So many practical skills that they develop as a result of being on that competition team. I'm really proud of them.
And they're in high demand by industry for
they
jobs
are that.
as well.
Yeah.
Well, when you walk into your buildings, sort of out there in the lobby, you got this really pretty car sitting there, the car of the future that Jim Bagley sponsored research on.
Yep.
Tell us about the car of the future. What was behind that?
Yeah, so that was completed about 8 years ago. So I'm not sure about our wisdom for calling it car of the future. We're not marketing people so much. We're very engineering oriented. But it was a great project, and we were so proud of it. The idea was for us to hang different outcomes from our research onto the vehicle. So it was a great idea. And so through the years, we've been able to do that. For example, the subframe is made out of magnesium. And it's a very exotic material, like titanium, has a lot of great strength to weight ratio, but it's very, very rare to see it in production. And so it has some research, some challenges, which was why we were working in research in that area. And that certainly illustrates one of our major areas of research is the materials and metallurgy, material science, since we were created in 2002, 2003. In addition to that, we have a model predictive control algorithm that manages the power source, whether it's a hybrid vehicle, so whether it comes from the battery or the small combustion engine, as a function of where we're at in the drive cycle. So, so that research is on there. Some additive manufactured parts is there. But I tell you, the most obvious thing, it's got a beautiful maroon paint job.
It does. Yeah, it does. Yeah. So I think most people think vehicles, they think cars. Yeah. But rockets are also vehicles. So I know that although it's been a while since NASA launched any space shuttles, CAVS has been involved in helping NASA with a few problems that they've had with the space shuttle. What can you tell us about that?
Oh, yeah. So certainly NASA has been an important funding partner for many, many years, and even predating CAVS, right?
Yeah.
So the work that we did in the early 2000s, mid 2000s, had to do with the Columbia disaster, and some of the earliest signature projects for CAVS dealt with the issues of the thermal issues with the tiles, and which of course led to the disaster. And so our high performance computing group, our computational fluid dynamics team, used the LOCI approach, which came out of the Engineering Research Center and became part of CAVS later. So that's one of the areas we've been able to contribute, is a more advanced understanding of the thermal properties of those tiles on the space shuttle.
Okay, so a lot of variety in the kind of work you do there now.
Yes, that is true.
And of course now you've sort of moved on a little bit and are now deeply involved in autonomy and autonomous vehicles. But you're doing a little special work, not just how do you get a car to drive down a nice straight road, but how does it work off-road? So what sort of challenges are you finding in that?
Everybody's is looking at the on-road stuff. You got Waymo and all these exotic companies, and it's like a gold rush, right? And so we decided we would take a little bit different tack and work on the off-road space. The idea was we would leverage these technologies that came off the hundreds upon hundreds of millions of dollars every year with the on-road autonomy and apply it to a different problem set, really a more challenging problem set, a problem set of off-road where you're dealing with a very dynamic environment. There's no lane stripes, there's no signs and stuff like that, and no rules. And so we began that probably around 6-7 years ago, but really accelerated that in the last few years around off-road autonomy. We have a vehicle fleet now that has our autonomy software on it. It's called Nature, and then we can put our autonomy software on everything from a small robot, a little remote control car, to a Polaris M Razor. Oh. Yep. So, and then we have a test area. We have a 55-acre proving ground for testing and validating our autonomy stack, and for validating the way the vehicle performs in real use. As with anything, particularly in autonomy, you also have to supplement and augment the physical testing with modeling simulation.
Right.
And we have a new modeling platform we call MAVS, Mississippi State University Autonomous Vehicle Simulator. And that allows us to do virtual testing of autonomy in these off-road environments. So we can create our own scenes.
Okay.
Yeah. So we can make a large mountain in our data set and test our autonomy, test our vehicles virtually.
So I know most people think about that, they think about controls, but cybersecurity is also important in autonomy. What kind of threats are you worried about in cybersecurity and autonomous vehicles?
Yes, that is an emerging area. There's multiple threats that could happen. you know, you can make your sensor system see things that aren't there, take evasive action when it's not needed. You could, you know, there's threats of controlling the algorithm remotely. And so that is a enormous risk for us as we go into the future. And so we've got to be able to develop these technologies in light of those challenges and really work to countermeasures against it so that we end up with robust, safe technologies that really do help us progress.
Yeah. Well, one question, we got a little bit of time left, but one question I want to make sure we get to is some people are sort of wondering maybe why all this research, what's important for it for us. And I know that CAVS and CAVS extension has had a tremendous impact on the economy of this state and of this region. Talk a little bit about what kind of impact you've had and how you've had that impact.
Oh, yeah. I'm happy to. As you know, I was at CAVS Extension for many years before I came into this role. And the CAVS Extension team goes around the state working with advanced manufacturers, helping them improve quality and productivity, and everything from automotive companies to shipbuilders to everything in between. And through those activities, we have to track the impacts of our projects and training, professional development training, as well as projects. And so we've been able to show about a $7.5 billion impact to the state since 2006, reported by our customers, with over 7,000 jobs created or retained as a direct result of our work. So we believe that's a good return on investment for the state of Mississippi, and it is exciting to see the growth in advanced manufacturing around the state since we were started in early 2000s.
Yeah. Certainly getting a lot more out of it than has been put in. We got just a little less than a minute left, so can you tell us briefly just what does CAVS Extension do that's maybe a little different from what you do here on the main campus?
Yep. So CAVS Extension is focused around the state. They will work with about 50 to 60 different companies a year, primarily manufacturers, in a wide variety of technology areas, but really is focused about how do we make our manufacturing operations safer, more productive, with higher quality outcomes. So that involves typically mechanical and industrial engineering type of activities. More and more, we see it involves robotics and involving computer engineering and some of the other disciplines. In addition to those things, project management is incredibly important. Also, the ability to work through teams and work as a team is enormously important, both inside CAVS as well as how we help our customers and our clients around the state.
Yeah. Well, we're certainly thankful for all the work you and your staff and researchers do, the impact they're having on the state as well as on this college. I want to thank you for taking time to come join us today. And I want to thank you all for joining us, and I look forward to seeing you the next time on Momentum.